Welcome to my tutorial, Become a Programmer Dart Programming Bootcamp. So what are you going to learn in this tutorial? We're going to take a look at the Dart programming language. Dart programming language is made by Google. It is object-oriented, which means that it resolves around data and not around functions, which are most languages actually, like the popular one like Java, Python and C# are all object-oriented. It has a low learning curve, which means it's really easy to step in. It has a high resemblance with other languages, so there are all kinds of concepts which are in Dart, as well as C#, Python, JavaScript, Java, which makes it really easy to adapt to another language after you learned Dart. Also, the programming language for Flutter, which is a mobile framework, which is really cool because you can build one mobile app and you can deploy it on iOS and Android. So after you've done this tutorial, maybe really cool to check that out. Also, this is a beginner's tutorial, which means that there's no prior knowledge needed. You will learn everything here from scratch. So what are you going to learn? Well, the basics of programming in Dart, and as I already said, these concepts also reside in other languages like variables, if statements, methods, classes, and so on and so on. But also, one thing that is really important as a programmer is to be able to look online for help, or to look in the documentation, or look at Stack Overflow if you run into a problem which you can't resolve on your own. Then it's really nice if you can look online for help. This is also a big part of being a programmer, actually. Also, why programming? Well, for me, that is of course, what makes programming really cool in my opinion is that you need a laptop or desktop, some knowledge, so how to program, a good idea, and with some extra skills you could be the next Airbnb or Spotify, because at the end of the day these are applications built by software engineers. But of course there's also other professions which are involved in building a great app, but still software engineering is the real core of these companies. The next thing we're going to take a look at is the editor that we're going to use. So most of the time when you go into the tutorial, you first have to install certain things like an environment, certain tooling, and this time, this is also a reason why I picked the Dart language, is there's an editor online. So we go to a browser and we fill in dartpad.dev. So this is an online dev environment, which means that we can run our code in the browser, which is really cool, and there's no setting up time to it. The only problem with this is that we can't keep our files once we delete it. To fix that, I set up a GitHub repo with all the lessons inside it. So if you go to this URL, which I also leave in the comments section, then here we can open up certain Dart files and we can take a look inside. So if I click here, there's nothing there, but if you click here on the branch, then you can see the code for each video that we created. So here, let's take a look at the if statements, then press on the file Dart, and then you can see the code that belongs to it, that lesson. So without further ado, let's start programming. As I told in the intro video, we're going to program in a website. And maybe you have the URL saved, but the website URL is dartpad.dev, as you can see. So we press enter and it opens up this web page. So what does it do? On the top side we have a header with some buttons, but we're not going to look much at that. But here we have three panels. We have this left panel, which is kind of big, and as you can see at the top here we have a console panel and documentation panel. This left panel is our coding panel. In here we're going to put the code that we want to execute by the web page. And the values that it's going to print out to this console window. If we click on certain stuff, we can see a little bit of documentation, and it also shows us a link where we can look for the right information. So if I, for example, press on this print, it's going to show what this print actually is. So it's saying that it's a function, and what it does, it prints a string representation of the object to the console. If we click here, it opens up another website, and here it shows the Dart core library where this print function exists in. But enough of that, let's go back to our Dartpad window, and what we can do now is click on this run button and it will execute the code that is between this bracket and this bracket. So let's do that. Let's press run, and it says hello 1, hello 2, hello 3, hello 4 and hello 5. Well, it does that because of this print statement right here. As we saw in the documentation, it prints a string representation of the object to the console, and that's what it's doing right here. But for you to understand this, you might need some experience in coding. So the first thing I'm going to do is delete this. So boop, that's gone. And what we're going to do is create our first Hello World app. And it's actually really simple. What we do is we type print when we want to use the print function again. We open up double quotes. So it's going to add 2 double quotes, and we're going to type in between what we want to print out to the console. So hello world. And as you can see, there's a red line under this bracket here. And if you look at the right bottom, you can see expected to find a semicolon, line 2. Well, line 2 is the second line, and because the red line is right here, if we hover over it, we can also maybe see, okay, really maybe, yes, expected to find a semicolon. And what this semicolon does, it tells the editor, in this case, or this web page, that this is the end of the line. In coding, the semicolon is really standard. If you don't put a semicolon, it doesn't know it's the end of the line. You can place your code however you want. If you want it to be like this, so separated over 3 lines, that's also fine, but it knows by the semicolon that these 3 lines belong to each other. So if we run this now, you can see that it prints out hello world. So that's quite a nice start. In this video, I want to talk about explicit and implicit typing, but especially explicit typing. So what is explicit typing? Well, in our last video, we used the var keyword. And the var keyword is a form of implicit typing. And what the compiler actually does is, based on the input, it's going to say what type this var is going to be. So when we put a text inside a var variable with a var keyword, which is a form of implicit typing, the compiler is going to determine that the variable is going to be of type string. And the type string is the same as text. When we put a number inside a var keyword variable, then it's going to say it's an int. I'm going to show you that by going back to our code. And when we click on this hello text, you're actually going to see that it says string hello text and not var hello text. Also, when we click on the number, you're going to see that it's saying int number and not string number. This explains the error that we get when we put back the text 5, trying to put it inside a number instead of a number itself. And it's going to say a value of type string, which is the same as a text value, can be assigned to a variable of type int, which is a number value. That's why you could also do that we delete the var keyword here, and we say that this is a string and this is an int. This way we can read by looking at the types before the names what kind of type it is. If we use the var keyword, we have to look at what's going in our variable, so what's defined here, to know what the type is of our variable. Well, when would you use implicit over explicit typing? In this case, I would be fine if there is a var here and here, because if you look at the inputs, it's really quick to determine that this is going to be a string and this is going to be a number. But let's say you have more complex logic and it's not that obvious what the type of the variable is going to be, then I would place here the explicit type and I would use the explicit typing. Well, there's one thing to bypass this problem, and that's the dynamic keyword instead of the var keyword. And what a dynamic does, it doesn't matter in what type of input you put inside a variable. If you run it now, it's going to run, But the problem of a dynamic is that you're entirely not sure what's inside your variable unless you're going through your code, and you're not going to see it quick by clicking here. As you can see, it now says dynamic number. And that's why I don't recommend using this. Sometimes, in some cases, it's handy, but overall, it just makes your code really difficult to read and to understand what is happening. And you would have to really look into your code to know what is happening to our dynamic variable. So I would recommend not using that. You can forget that. But still, I had to show it. And we use explicit typing here, or you can use the var keyword as I just said. And let's delete this. Well, you have other types which are known as primary types, which are much used just as the string and the int. And one of these is the boolean. And what a boolean is a boolean can have two values. It can be true or false. So that's really easy. We can set it to false. And if we print that out and run the code, then you can see that it's going to say false. So that's really simple variable, but it's actually really powerful. And you have also other types like dates, datetimes, timestamps, and doubles. And how doubles work is that these are numbers with a decimal. So if I type here .0, it's going to say that you can't put a double inside an int variable. But if I change this up to a double and then press run, then you can see it's still printing out the same. But would I change this to 0.4, then he would print out 0.4 instead of 0, as you can see. So to start programming, we first need to talk about variables. So what is a variable? And really plain and simple, name for a storage area in which we can put data. This means that in a variable we can store data and we can use a key to use this data in certain contexts. So how you could imagine this is that we have a certain value inside a certain box which we only can open with a certain key / name, how you want to call it. So the value could be hello world, just as we did in the last video, and the name could be hello text. What is this going to look like in code? In code we have a var keyword, which indicates that it's a variable. Then we have the name / key, and then we have an assignment operator, which is the same as an equal sign, and then the value of what we want to put in this variable. So in this case, hello world. And as you can see, don't forget the semicolon, because this is the end of the line and this is the command that we want to execute. If we now go back to our code and we have here the print and hello world, we can place this hello world inside a variable, just as I showed in the PowerPoint. So let's do that. We're going to create this value, hello text, and we're going to say hello world, exclamation mark, semicolon. As you can see, there are no errors, but what it shows us is a blue line under here. And what it says is the value of local variable hello text isn't used. That's because we didn't use this variable just yet, but it says, hey, if you're not going to use it, please delete it because it's unnecessary. So what we can do now is let's delete this. And we use now the hello text to delete these spaces. And as you can see, both errors are gone. And if we run now, we are still seeing hello world. But to show that it's actually working, we're going to type 2 exclamation marks behind it and press run. And now we have 3 exclamation marks. So that works pretty fine. What we also can do inside a variable is declare a number. So you can use var number and then just press 0. We don't need to put quotes around it because quotes is for text, and numbers you can just type the number itself. Press a semicolon and the red line will go away. And what we can do is also print this number. And if we run now, we should see 2 things inside our console, the hello world and the 0 that we put in here. We can also change the value that's inside a variable. So if we want to change the number from 0 to 5, we can use the key, which is number, and I can press now 5 and semicolon. We don't need to declare this var keyword again because the variable is already created. And when we create a variable, we have to define what kind of variable it is. We now use the var keyword, which is a form of implicit typing, which we're going to talk about in the next video. But if you already created the variable, you don't need to declare what it's going to be, of what type. So we are now able to use this number and then say it's 5, and we can print it out again. And run. And you can see that now this 5 also is put inside our console. Now what happens if I try to put a text inside a variable which was actually a number? Let's try that out. So we can type here a number, and then we say maybe also the same 5, but now it's a text because we put it in quotes. And what it's going to say is a value of type string can be assigned to a variable of type int. So in this video we're going to play around with integers or numbers, and let's go straight back to our code. And what I'm going to do is actually delete this stuff, and we're not going to use it, and I'm going to define some new variables. So I'm going to define that int a is 3 and int b is 2. What we can do now is we can set a new variable with these numbers and use an operator on it. So we can add two numbers to each other, we can times it by each other, or we can subtract it by each other. So what we can do is we set int c is a plus 2. And if I run that, then you're not going to see anything because you still have to print it out, of course. So let's do that again. And as you can see, it says 5 because our a is 3 and we did a plus 2, which is 5. That's quite simple. So the next thing what we can do is we can also times it, or we can subtract from each other. We can also do a times c, and let's print those out and run the code, and let's see what's happening. So a is 3, b is 2, c is a times 2, which is going to be 6, that's right. D is I minus b, which is 3 minus 2 is 1. And then we say a is 3 times c, which is 6, and that's going to be 18. So this way we can play around a little with numbers. So we have also the option to set a variable with something different in which we can use its own value. So let's say that I want to set a with the value that's inside it plus 2. So what I can do is a plus 2. And I'm going to print that out and run. And as you can see, it says 5. This easy way when you just want to hire up a variable in a certain case. But there's also a quicker annotation for this. So what we can do is we set a plus is 2. And what it's going to do now is going to take the number and plus it with 2. Just as it did before, but this is the short syntax which is called. So this was a quick intro into numbers. In this video we're going to take a look at strings, as I already mentioned. So we're going also straight back to our code, and what I'm going to do again is delete this code that's inside our main function. Let's define some new variables. So I'm going to use the string type, and I'm going to call it text a is, and I'm going to use my first name, and let's just call this variable first name. Maybe is that a little bit easier. So first name, and then I'm going to use another variable which is going to be surname, and my name is Kesvingul, and I missed the semicolon, so it's going to nag about it. And I'm going to console these both, which is actually print. In C# it's console log, so I'm going to print these to our console. We can now delete this library, so let's delete that and let's press run, and it's going to print out gas fan cool. Wait, it's taking a little bit longer than I expected, but yes, there it is. So now what are we going to do if we want to print out the full name? So what we can do is we define a new variable, which is full name, and I'm going to say first name plus surname. So what it's going to do is it's going to put this piece of text in front of this piece of text. So if we now press run, but first let's print that out. Yes, and run it. Then you can see that it puts actually the text straight to my first name. So now instead of cat fan cool. And we don't want that. And the way we can fix that is putting a space between these two values. So if I run it now again, then it should be written out the right way. So we can do this and for many variables, and this way you can create a whole piece of text. I wouldn't recommend that, but you can if you want to. And what we also can do to fix this is use string interpolation. And how this works is we can set a new variable. And I'm going to say it full name too. And we open up quotes and we use a $sign, and then we can say first name and then a space and then again a $sign and press a semicolon. So what it's going to do now is it's going to take the text that we have here and it's going to print out first name at this position, then puts a space between it, and then going to print out surname in that position. So let's see if this is working. Then I have to type the name right, and let's press run. And as you can see, it's still working. So what we can do now is we can put text before it. So full name double dot and then press run. And it should now write out full name double dot cat van gool. So that's really nice. And the plus or the addition operator, which is called, is actually the only operator you can use on a string. So you can't use a minus or a separator or the time sign. Only the plus operator is working. If we try it out, then you can see that first name is first name minus surname. Then it's going to say that that operator isn't defined for a string. So this way you know what you can use or not. And that was it for this video. So strings, quite short, but still handy. In this video we're going to take a look at string functions. And what I mean with string functions is that we can call a function on a string, a variable that we defined which is of type string. So let's go to our code, and we have got all these kind of strings here. And the first thing I'm going to do is I'm going to type the variable, and I'm going to use the full name too for now, and type a dot. And if you type the dot, we can see what the options are. And with functions we can use, but also some variables, which is like the is empty or the length or hash code. I don't know where that is, but still it's available. So what we can do now is let's print out some lengths. So let's print out the length of the first name, dot length, semicolon, print out the length of the last name or the surname, and let's run it. So the first one is 3, so 1, 2, 3, and the next one is 8, so 1, 2, 3, 4. The space is also a character, and then 1, 2, 3, 4, which is 8. So there are many other things we can do, and this is one of the more interesting maybe, but also very simple. So we're going to take this full name too, and we're going to say uppercase it. Okay, I did something wrong there, so dot, and let's go below. Oh, it's still uppercase. And these two brackets behind this means that it's a function, but it has no input parameters. So if you click on it, you can see that it converts all characters in the string to uppercase. So let's run it. And as you can see, everything is written out in uppercase. But if I print out now the full name to itself, do you think it's uppercase or it's still the way it was? So let's check it out. Let's run it. And as you can see, it's still the way it was before we used the uppercase. And that's because this function doesn't set the value of our full name to. It's just going to give us an uppercase representation of what's inside the full name to. You could do the same with to lowercase and press run. And as you can see now, these F, C, and G are gone and are lowercase. So these are the simpler functions. We've also some others which are a little bit more difficult and use some inputs. So what we can do is we take a look at what we get, and let's take a look at index of. So it explains a little here. So it returns the position of the first mesh of pattern in this string starting at the start. So what this means is with these block brackets, they say that the input isn't needed. So we could only give in the first input, which is the pattern, or it's just a string. But we could also give in a new regex, and this is something different which is outside the scope of this tutorial, but still, if you want to look at it, then you can use regex or RAG, just like here, the first 5 characters here. So what we can do now is we have here a full name too, and we know that there's somewhere fan inside. So let's take fan, and if we run it now, we have to put that inside quotes. Now it's fine. If we run it now, we're going to get back the first index of this fan. So this means that this V is on index 14. So let's check it out. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So how does this work? The index is at 14 because the first index is 0. So you have to subtract 1 from the length if you want to know the index of the last character. So let's take a look at a function which is a little bit more difficult, which actually takes 2 inputs, which is the full name and the substring. So we have a start index and end index, and what the substring does is, if we click on here, is we can get a certain piece of text out of our string which is between certain indexes. So as you can see, we have a start index which is not optional, and we have our end index which is. So if we put now here from 5, it's going to give us back the string which is after index 5. So let's run it, and it says that aim double dot gets my goal. So let's check it out. 1, 2, 3, 4, 5. So it's going to give back everything behind the 5th index, included with the 5th index itself, which is the A. So that works fine. But if you now say 8, so comma 8, which is for the end index, then we should get back a tinier string, which is the just aim. So these are string functions. If you want to look it up, you can also go here, dart class string, and then you get the string class dart code library, And Dartcore library is the one library you are always using. So this dartpad is also using the Dartcore library, but because it's mandatory, it's not an import or anything. So here you can see the string class and some examples, but also we have constructors, which we're going to talk about later on in this tutorial. We have properties and also these methods or functions, which you want to call it. And that's it for this lesson. The next we're going to look at are booleans. In this video we're going to talk about booleans. Well, as already mentioned, a boolean can only have two values, true or false. So let's create one. We start with a bool keyword, which is short for boolean, and I'm just going to call mine boolean, and then I'm going to set it with true, and I can set it with false, and we can print it out to our console. And we run that, and only false to be shown. Okay, alright. But where booleans come to shine is when we use relational operators. And the way we can use relational operators is to check if something is the same as another thing. And I'm going to show you how this works. If we define an int a, which is 5, and then an int b, which is 4, we can check if these two are the same or different. And the way we can do that is by saying boolean is a is this b. And if you click on this operator, you can also see the documentation, and what it does is test whether this value is numerically equal to other. And what it means is this value is the one that's before the is operator with the other, which is the b. If I print this out to the console, we should see that it's going to be false. And that's because 5 is not 4, which is kind of obvious, but still. Let's see what the answer is, and it's going to be false. What we can also do is we can check if these two are different from each other. And we can do that by using this exclamation mark and then an is sign instead of double is. If we now print it to our console, boolean, semicolon, and then run, you will see that's true. There's also different operators, just like we are used to using maths, which are the lower and the greater than operators. So let's use these both. That should be a b, and we can also say higher and equals than to, and then print it out, semicolon. And if we now run this, then we can check what the answers are. So the first one is false, and that's because the boolean is just set to false. The second one is false because 5 is not 4, so boolean is false. The third one is true because indeed 5 is not 4, so it's going to be true. Then the fourth one is going to be false because 5 is not lower than 4. And the fifth one is true because 5 is greater than or equal to b. What we can also do is check if two texts are the same. So the way we can do that is by just doing the same as the numbers. We take two texts, hi, and text b is hi. And we try and compare these to each other by using the is operator. And we print it out. But these two are actually the same, but they are still different because I use the uppercase here instead of a lowercase. So we expect that it's going to be false, and this is true. I mean that it's false. Sometimes you want to check multiple things at the same time. So if A and B are the same, then B and C should not be the same. And we can do that by defining another number. And we can say here, boolean is A is unequal to B, and B is equal to C. What now happens is that we're going to check if A is unequal to B, and we're going to check if B is equal to C. If that's the case, then we are going to say true. But if one of these two is not true, then it's going to be false. If you run it, then you can see that the last value is true. And to show you that the statement is false when one of two is false, I'm going to say that A is unequal to B and B is equal to A, which will always be false because A can be unequal and at the same time be equal to B. So if you run that now, you're going to see that it's false. Sometimes we want to check if one of the two statements is true, and we can use this by an OR operator. So it now says if one of these two is true or they both are true, then it's going to be true. If they both false, then we're going to print out false. So when I run this now, you can see that's true again. In the next video, we're going to look at if statements where relational operators will really shine. In this video, we're going to talk about if statements. So if statements are the first piece of logic that we're going to include in our code, and let's talk about what it does. So an if statement is a conditional statement that performs code when found true. And how does it look like? It's really simple. We have an if keyword right here, and then we open up brackets, and then we put inside a boolean value, and when this boolean is true, then we're going to execute this piece of code that's inside these two brackets. So let's jump to our code and let's just use it so it's more easy to understand. So we delete the code that we have here before. Don't worry, you can look it back up when you want to. And I'm going to start with two numbers. Int A is 5 again and int B is 4. Now I'm going to say that if A is the same as B, B is going to be B plus 1. And we're going to print out B. So what do you think that it's going to print out? If you walk through it from top to bottom, it's going to say int A is 5, int B is 4. If A is the same as B, which is not the case, then we're going to skip this code and then we're going to print out B, which will be 4. Let's run it. And as you can see, it's 4. If I change this up and I say it's not the same and I run it, then it will execute this piece of code, which will say that B is B plus 1. So B is 4 plus 1, which will be 5. If I now run it, then you can see that it's 5. Let's say that we want to check that A is not the same as B, and at the same time we want to make sure that B is lower than A, otherwise we won't run this code. And what's going to say now? Well, A is not the same as B, and B is indeed lower than A, so it's going to say 5 again. And to show you that it's actually working, let's change it up to 2, and when we run it, it's going to say 6. So this was a really quick intro into if statements, and the next statement that we're going to use is the else statement. In this video we're going to talk about the else statement or the if-else statement, and to do that we're going straight back to our code and we're going to build further on the code that we already have. So we know that this piece of code is going to be found true and that this piece of code is going to run. Something that's intertwined with the if statement is the else statement. And let's say that we want to actually lower the B if we run this piece of code by not saying an addition but a minus, and let's run it and see if it does any different. So let's run it, and as you can see it still says 6, so it didn't do anything. But what happens if I now delete this piece and instead of an unequal sign I say an equal sign? So is B going to be the same as A? Well, they won't, so this is going to be false. So what is it going to do now? If we run it, you can see that the answer now is 2. And that's because when if statement is not true, then it's going to look if there's an else statement. If that's the case, then it's going to run the else statement instead of the if statement, and it's going to execute this piece of code. You can actually chain these two to each other, and you can create an else if statement. And how this works is, I'm going to say something different, and again else, I'm going to say that b is b times 2. Now you might wonder, how is this going to work? Well, it's actually really easy to read, because it's going to say, if e is equals to b, then b plus 2. If that's not the case, is e lower than b? If that's the case, b is b minus 2. If that's also not the case, then we're going to use b is b times 2. And let's run it and let's see what it says. It's going to say 8. Well, a is not equal to b, so it's not going to run this. It's going for the else statement. And a is not lower than b, because a is 5 and b is 4. So it's not going to also run this statement, and it's going to the else statement of this if statement, which is b times 2. So this was a really quick intro. You can also play around yourself. So if statements are really nice if you want to put some logic in your code and you want to do certain actions based on certain contexts. So this way you can define what it should do when a is the same as b, a is lower than b, or a is higher than b, or a is 2 times higher than b. And maybe you want to do something different in each case, which is the if statement great for. In this video we're going to take a look at the while statement, and because it's a lot similar to the if statement, but only the way it executes the code is different, we're going straight to our code. So here we have our old code, and I'm going to delete this. I'm going to leave the int a and int b, because most of these statements are easy to show with numbers. But instead of a is 5, I'm going to set this with 0. And how the while loop works is, just as if the if statement, we define a keyword, which is in this case while, then we open up a bracket which expects some boolean, and then we open up curly braces in which we put the code that we want to execute if this boolean inside our brackets is true. So let's print hi here, and to show you how it works, or not show you how it works, I'm going just to say true. And the problem of this is that this while loop is never going to resolve. It's going to say int a is 0, int b is 4, and then it's going to check if this while is true, which is always the case, and then it's going to print hi. If I now press the run button, my browser will probably crash because of that it's going to be stuck in this while loop forever. So just to show you, I'm going to press run. And you can see it says that it run, but if I now click somewhere, it's actually broken. So to fix that, I'm going to open up another tab, open up the dev pad again, and close this one. So this is not something that you want to do. Let's leave that out of here. And you always want to put in a statement which is eventually going to be false. So let's just put in 100 here, and I'm going to say if a is lower than b, then we're going to print out a, and after we print it out, we're going to increase a by 1. If I now run this code, it's going to check if a is lower than b. If that's the case, then it's going to print a, then it's going to increase a with 1, and then it's going to check again if the statement is true or not. So if we run it, we should see all the numbers from 0 to 99, I guess, because in the last case, when a is 100, then it's not lower anymore than b. So let's check if my assumptions are right. So as you can see, the last number is 99, and the first number is 0. So when do you use a while loop? I have to admit, when I work professionally as a programmer, I don't use while loops that much because there are actually better alternatives in many cases than the while loop. And one of these alternatives is the for loop. In this video we're going to take a look at the for loop. And the for loop is a little bit different than the while loop. And what the Wikipedia is going to say is that it's a loop that needs to be executed a specific number of times. Well, what does this look like? The for loop starts with the for keyword, just like the while loop and the if statement, but instead of that it just takes a boolean. We actually need three values: the init, the condition and the increment. And these three work a little different. To show you, we're going straight to an example. This is an example of a for loop. So the init is everything that's before the first semicolon, which is int e is 0. And this init is fired off the first time that we enter the for loop. Then we have the condition, and just as the while loop, it's condition when it's going to leave the for loop. So as long as e is lower than 5, we're going to run this piece of code. Then when the code has run, we are going to say e++, which is going to increment e by 1. So then let's jump to our code and let's implement this for loop so we can see what it does. So we're going to delete this code and we're going to say for, we're going to define the init, which is going to be int e is 0. Then we're going to say that e is lower than 100. Then e++. Then we open up curly braces and we're going to print e, semicolon. So when we run this now, it's going to set e with 0, then it's going to print e to our console, then it's going to do e++, so e is going to be 1, and then it's going to check if e is lower than 100, and then we're going to print it again. So if we run this now, then we can see what it does. Well, the first value is 0, and the last value is 99. And that's because the last value, which is actually 100, this e is actually 100, then it's not going to be true anymore, and it's not going to write it out anymore. And that's why the last number is 99. What do you think happens when we print this e out after the for loop? Well, the problem is that we can't do that, and this is because of scopes. And as you can see, when I try to do this, it's going to say undefined name e. And we're going to take a look at this problem in the next video. In this video, we're going to talk about scopes, and to explain what scopes are, we have to go back to our code. So as you can see, the problem with our e variable still exists. It says that it's undefined and that it can be used at this row, or at this line at line 5. And that is the problem of scopes. So we have three scopes at the moment. We have the scopes of this whole file, so from top to bottom. If we place some enters here, this still belongs to the scope, so this is 1. Then we have 2, which is this void main method. And then we have 3, which is this actual for loop. And scopes always work from the outside in, but never from the inside out. So what this means is, if I declare a variable, something 0, and I set it here with e, that's fine. It's going to work, there's no problem. But if I take this outside here, then this isn't going to work. Also, if I try it here, so outside here, it's also not going to work. But let's say that I'm going to delete this and I'm going to set it here, and I'm going to put this for something right here. It's still going to work because it's now in our outer scope. So this is the biggest scope at the moment. We have now declared something in our global scope, it's called. And we can use it now in this method, we can use it in this for loop. If we declared another method, so let's say that we declared another void main2 method, that's also going to be fine. and we can still use it. And as you can see, we have still here the same problem, but these two methods are both referencing this same something variable. And maybe this is something that you not want to do, but that I'm going to explain in the next video. We're actually going to start build an application with some logic, and we're going to play around with these concepts that we just learned, and we're also going to learn some new concepts. But then you can see how it works in certain contexts. So let's take a look at methods. In the last video, we registered animals through our register animal method. But at this point, we aren't able to keep track of which animals are actually registered. And the way we can do that is using lists. So what is a list? A list is an object that holds specific variables in a specific order. And this is what it looks like. So we have here a list with between diamond text string, then we have the name and then something behind. So the first thing is the type. So here we have the type list, which holds variables of string, and then the name, and then a constructor. And a constructor is something we're going to talk about in a video later on. So as I already said, between these diamond tags we register the value of which type this list is going to hold. So what is this actually going to look like if we're trying to add an animal to our list? Well, we can call our animals list, and then it has a method or function which is called add, and then we can give in something of the type of which we registered the list. So this time it's type string, and we're going to add Hank the dog. Then inside our list, at the first index, which is actually 0, there will be a value registered of Hank the dog. If we then call another time, and this time Fred the cat, then Fred the cat will be registered at the next index, which will be 1. So let's go to our code and let's start implementing this list. Well, where are we going to register this animals list? I'm going to register it at the top of the file, so we can also use it in other functions and not just our main method. So I'm going to type list string and then animals, and I'm going to say new list string. Then we're going to add our animals to this list. And where can we do that? In our register animal method. I'm going to delete these prints, and then I'm just going to say animals without the uppercase, and then you can see it's helping us. It's saying add, yes, and then I'm going to use some string interpolation to type out this string, which is going to say Harry the dog or Fred the cat. And then I'm just going to return true. So let's run that, and now we only see true, and then we can print this animals out, and let's see what it does. And as you can see, we have here something that we call an array of the values that's inside our list. So the first value is Harry the dog, the second is Fred the cat. What we now are able to do is to access a certain value at a specific index. We can say I want the animal at index 0. We can do that by these block brackets. If we then run, then you can see that it's saying Harry the dog. We can also do this for 1 and then run, and then you can see Fred the cat. But what happens if we try 2? There's no animal registered at index 2. We know that because we only added 2 values, and the first is going to be 0, the second is going to be 1. So what happens now? So now we did get an error. And what does this error say? So uncaught error, range error. So this is the type of the error. And then index out of range, index should be less than 2. It's actually saying, hey, you're trying to call index 2, but it doesn't exist. So maybe don't try that. And if I try 1 now, it's going to say Fred the cat. So that was the first exception which you saw, and we're going to talk about that in a few videos. So what is handy about this actual register method? Because in this case we could also just copy this and paste it here, and then we don't have the hassle of this method. Well, in many cases, when you get input from users, you might want to validate if these inputs are actually what you expected. The way we can do that is by actually using an if statement. So let's take a look at this. I can say if, and if I then use the name variable, there are all kinds of things I can do. But there's also something which is called isEmpty. Returns true if this string is empty. If I do that, and then just return false, then when our name is empty, the animal won't be registered to our list because it already found a return value. So if our name is empty, it's going inside our list, it's going to return false, and it's going straight back to the caller of our method. So if I now put quotes here, so this is a string empty, and just print this out, you will see that only Harry the dog is registered to our list. And that's because this is now an empty value. We can also do this for our kind. So what this says now is that if the name or the kind is empty, then we won't want to register it to our animals list. And this way we can put all kinds of validations inside our register animal method, and it doesn't clutter our main method in which we type everything that our program actually needs to do. But there's also another way to do this, because the only problem now is that we have a boolean here. So why is that a problem? Well, if this is a real world scenario, so let's say we have a web page and somebody filled in their name is empty, and we only get in return a boolean, we can only say, hey, something went wrong. But it would actually be nice if we could say, hey, you didn't fill in the right name or the right kind. And that's why we're actually going to use exceptions to give us a return value of what was going wrong. And I'm going to show you that in the next video. So in the last video we saw the index out of bounds error or the inner range error, and I'm just going to show you it again. So if I now say animals.0 at the top, then if I run it, then we're going just to see this range error, and it says that index out of range. So it didn't find anything at the 0 index. But something that's much more interesting is that the whole program stopped. As you can see, we didn't have any prints anymore, so we didn't see if it was succeeded or not, or the animals. It just found this error and stopped the programming. And that's something that's really important about errors. If you don't manage these errors, then it's just going to break your program, and most of the time then a user will see some weird page in which it's going to say range error, index out of range, and the user doesn't know what to do. So it's important that if you work with errors, that you're able to handle them. So instead of this bool, in which we are returning now the whole time, I'm actually going to turn this into a void. And what is a void? Well, a void method is a method without a return value. So these return keys can go away. Now also this succeeded isn't necessary anymore, and we're just going to delete that because it's not going to return anything anymore. Something that I also wanted to do before we go any further is to fix a little bit of our code that it looks a little bit better. So I'm going to delete this also, and I'm going to place some comments. So here we have our initialization of certain variables. Then I just want to put these two with each other. So this is actually the program that we are running. So functional, how to call it. And then I'm going to say a conclusion. And why I do this is because our code will get much bigger and it makes it a little bit easier to read. Init variables also. So now we can see if here we are initiating variables, then we have here our register animal function. So here we're going to put all the code that we're going to do, and then we are going to at the end doing some stuff to check if everything went the way we expected it to be. So now let's start with an error, and we can actually produce an error ourselves. So how do we do that? We go to this if statement, and instead of this return false, I'm going to say throw, then new, and then we can choose what type of error, and I'm going to call it, I'm going to use the argument error. And the argument error is an error which expects a message which can be anything, but we're just going to use a string, and it's going to produce also this kind of error, but instead of the range it's going to be an argument error. And I'm going to say the value was empty, and if an animal got registered, I'm going to say here animal registered. Now if we now run this, if I'm right, then we will see the first time that an animal got registered, and then the second time we're going to see this argument error, and then this print won't be run because this argument error was caught. So we run, and as you can see, this animal registered, then the value was empty, so the message that we typed in here is now showing, and then it didn't print any animal values or anything. So to make it more specific, I'm going to separate these two inside our if statement, and I'm going to give this its own if statement. So kind is empty. Now we can say the name was empty, please provide a name. And now I'm more thinking inside website context. So if our user didn't fill in a name, then we're going to say, hey, can you please give in a name? And if he didn't fill in a kind, then please give in a kind. So now based on which value was empty, we can see what kind of error we get. So if I now run it, then we should see the name was empty, please provide a name. And if I now type a name here, we'll just use the name too, and now give in an empty kind value, and then run it. Then we are going to see the kind was empty, please provide a kind. So input validation is something we do a lot in programming. That's because when we are using this value later on, we want to make sure that everything that we put inside our code is the way that we expect it to be. So we don't want empty names, we don't want empty kinds, we want only animals which have names and kinds, because later on we maybe say, hey, do this name uppercase, and then the name is empty, and yeah, we get all sort of weird things that we can't explain, and it's better than to make sure that the data that we expect is also given in, and if the user doesn't give in the data we want, then we can tell them, hey, this is not the right format, or hey, this is empty and we expect it to be a certain value. So the problem is right now is that when we fill in something that's going to give in an error, then our whole program stops, and that's something that we don't want. We just want to know if something went wrong, then notify us please, but keep on running the program. And I'm going to show you that in the next video using the try catch statement. In this video we're going to take a look at classes, but first let's take a look at why we need these classes by looking at the problem. At the moment we have a string animal with a name and a kind inside, and these are separated by a space. Let's say that we want to add a height and the age. then it would start to look like this. And the only way to get these values out is with this split method. The problem of this split method in combination with the values in a string is that we don't know which way these values are ordered inside the string. Of course we do know now, but let's say you're building an application and 5 weeks from now you would need to see where the age is. Now I can see that it's at place 4, and I would have to look back then to how I added to the list and then see, oh, it's on place 4, and then I have to use the block brackets and use the tree to get the value out. But there's a much simpler way to do this, and there's where classes come in. So what is a class? A class is a custom type, just like string, int and all like that, in which you can bundle variables, methods and more. It's fairly simple. We have a class keyword with a name behind it, and this is the name of our class. Then we open and close brackets, and between these brackets we put the code, the fields, the variables, methods, everything inside that belongs to this class. So in the case of name and kind, we just add string name and string kind. Fairly simple. These two are our fields that resides in this class, and we know that every animal instance, is what we call it, or object, has this name and kind field. You could say that a class is a blueprint of how fields and methods work with each other. How is this going to look like in code? We have instantiating, getting and setting. So instantiating is creating an object of this blueprint. So we can create multiple objects that use this blueprint. So for our hairy dog, we could say animal hairy dog is new animal, and we could say for our cat animal Fred cat is a new animal, and we could call this a million times, and we would create objects of this type. Actually, it's a little bit the same as strings. We are whole time creating an object of type string with a certain text inside. So this is only the boundaries of what you can do with this type. To read values out of our animal class, we can use getters, and it's fairly simple. You take the name of the object that you just created, and then we use a dot, and then we can choose the property, field, variable, these are all the same actually, that we want to read. So we can say animal.name, and we can use it in this string name variable. We could do the same for kind. If we want to set it, it's just the other way around. So we say animal.name is Harry and animal.kind is dog. Let's just put this in code, and maybe it gets a little bit more understandable when we use it. So we're back here in our code, and I'm going to scroll down below this make sound function method, and I'm going to create our class just like in the PowerPoint. I'm going to say class animal, and I'm going to give in string name and string kind. We are now able to create this animal, so let's do that. Animal, and we can also see if we just type anim and then control space, it's going to say here animal, and then I'm going to call it Harry for now and say new animal. So now I created an object of this class called Harry. If I now type Harry dot, you can see that our properties pop up. So kind and name fields is maybe a better word, just to make it less confusing. So I could set this name with name1, and I could set this kind with kind1. And if we now print our Harry object out, so let's take a look why it's oh, I forgot the one here, and then run. Then we can see instance of animal. That's why it's called instantiating, but it's now reading out something of how this class is called. But we can also print out the name that we filled in. So here we set the value, and now we're getting our value. Let's run that. And as you can see, it now says Harry. So the way we can use this is, instead of using these strings everywhere, we're now actually going to use our animal object. So we're still going to keep these. We're going to delete this for now. And instead of animals add a string, we want to add an animal object. So the first thing I have to do is, instead of list string, I'm going to create a list of animal. Now we will get all kinds of errors because we can't split a string and we can't add a string to our list because our add method now expects an animal object. So let's create this animal object. Animal is new animal, and we are going to set these animal.name with the name and animal.kind with the kind, and then we're going to add this animal to our list. So that one is fixed. This line isn't necessary anymore because we can now say animal.kind. That's because when we click here, you can see that this animal is now of type animal and not of type string. So all our errors are fixed now. Let's run our code and see if it's still working. As you can see, it's still working, but it now says instance of animal instead of a name. And we're going to fix that later on in this tutorial by overriding a certain function, but for now let's leave it as it is. So this was a really quick intro into classes. Don't worry if you don't get it at this point. We're going to look at it in many more videos, and I will try to explain it as clearly as possible. In this video we're going to talk about constructors. So first let's talk about what constructors are. Constructors are contracts for instantiating an object. So at this point we created our animal class with our string name and string kind, but this is what we see. On the background, our code generated a simple constructor for us, or the default constructor, which is just this animal, and then we open the brackets and then our semicolon. And what this default constructor does is it makes it possible to create an object of our class without any input. So this instantiating is possible because of this constructor. We can change this constructor by saying that it needs certain inputs before we can create an instance from our class, like this. Now we say, if you want to construct our class, we need a name and we need a kind. And the way this looks is something specific for Dart, but I will show you that in a later video, what I mean by this. So now, when you want to create an animal object, you have to give in a name and a kind. And to show you that, let's go to our code. So here's where we left off in the last video, and let's take a look at this constructor. So what I can do now is I type here, low here, I type animal, brackets and semicolon. And as you can see, nothing changed about the code. That's because we actually typed out the default constructor that normally would be created for us on the background. But now let's change it up and let's give in our name and kind. And as you can see, we have now an arrow, and if we click here, we can see that 2 positional arguments expected but 0 found. And when we click on it, we can see that our string name and string kind are defined here. So if I now delete this again, and I click here, then you can see that it's empty. So let's change that back. And what we can do now is, instead of this, we can delete this. And we can now give in our name and kind directly into our constructor. And our object will now be set with the data that we give in. So if I now run it again, then we should see the same things. But to make sure, I'm going to print out the name value of the animal that we are going to add. Semicolon. And let's run that. And as you can see, we now have Harry, Fred, Larry, animal registered. So that works fine. This was a really quick intro into constructors. In the next video, we're going to take a look at what we can actually do more with these constructors. In the last video, we had a really quick intro into constructors. In this video, I want to take a look at some design choices that we can make with these constructors. So for that, we go back to our code. And what's really interesting to me is this part of our code. So we have here the input validation that we do before we create our animal class. But now the question you might want to ask is, do we want to leave the input validation to the code that implements the constructor, or do we want to leave the input validation to the constructor itself? In my opinion, it's better to leave the input validation to the class itself, and that's because when we are going to use this class in another place, we know that our class is going to be used the way that we designed it to be used. So I'm going to change this constructor a little, because this constructor is something in Dart which makes it really easy to create a really simple constructor. But I'm going to write out what it actually does behind the scenes. So I'm going to leave this constructor for now. It's going to cause some errors, but don't mind that. So what the constructor actually does is it expects a string name. And as you can see, if you click here, you can see that it does expect a string name and a string kind. So string kind. And then we open up curly braces, and what it actually does is it sets the name of our object to the values that we put in. So if we delete that old constructor now, this is what that constructor actually did, but it generated this code for us by using that implementation. So what we can do now is we take this input validation, we cut it out of the code and we place it right here. And now we know for sure that when somebody uses this constructor, that there will be input validation and that you don't have to create each time that you implement this constructor, you don't have to check the inputs because the class will do that for itself. So if I now run the code, everything should be still fine. And if I now leave this empty this way and run, then you should see some errors. And as you can see, we have 3 errors and it didn't create anything because for every animal that we are going to create, the kind will be empty. This way we are able to make sure that the data that we expect is used inside our class. But there's still a workaround around this, and this I'm going to look at in the next video. But something that could still be a problem is that if somebody calls this animal.name, it can override it still with an empty string, and then we still have an object with an empty name, which isn't what we want. So let's take a look at some things that we can do with properties. In this video, we're going to talk about access modifiers. And access modifiers determine how our properties methods are used outside the class that defines these. And in this case, I'm going to talk about properties explicitly. So to do that, let's go back to our code. And at this point, as I showcased in the last video, is that we are still able to modify this .name after we constructed our object. And sometimes you don't want this, sometimes you don't care about it, but in this case I don't want that. I don't want people to be able to modify the name outside the constructor. So the way we can do that is by changing the access modifier. So at this moment we didn't determine any modifier, and the default access modifier is public. And public means that everything is accessible outside the class itself, and that's why we can call this animal.name and also here this animal.kind. But if we want to change that, we can set it to private. And in Dart, it's fairly easy to set something to private because the only thing you have to do is to set an underscore before the property name. And as you can see, we have now got some errors. So when we set it to private, it should only be able to be used inside the class itself. So if I change it to underscore, then here is it fine. And if I change to underscore here, then we should still get an error. And as you can see, that's not the case. So that's really interesting. And after some research, I found that the problem is that this class is in the same file as this code. And to showcase this, we're going to open up an editor. And as you can see, we've got here our code. And if I now copy paste this, then you can see that everything is still fine. Our editor isn't showing that this property isn't accessible. But if I define now a new file here, so I'm going to call it animal.dart. And instead of defining our class here, I'm going to cut this out and print it here. Now it's going to say that it can't find a class, so we have to import the library itself. Press enter. And as you can see now, it says the setter underscore name isn't defined for the class animal. And that's because it's private now. So in Dart, which I found very interesting because I haven't seen this before, is that in Dart, private properties are file-based and not class-based. So if you put the class in the same file as something different and you set it to private, it can still be used inside the other class because it's in the same file. So for now, inside our website environment, because we have everything in one pad, it's called on the website, private properties aren't working, but in this case you can see that it actually works. And normally I would separate these files, so this is the proper way to work, I guess. So we're just going back to our Dart file, and as you can see, it still works here. If we were able to create a new pad outside this pad, then it should be fine. But let's leave it for now. So let's change it back here to name. To name. So it doesn't get more confusing. So we aren't actually able to fix this in this way, but there's another way to do this. And that's with the, let's change this back too. That's with the final keyword. And the final keyword is something interesting. The final keyword says that the name property can only be instantiated inside the constructor and not anywhere else. So as you can see, we have now an error that says all final variables must be initialized, but name is not. And the interesting thing is that we are actually doing this, but Dart expects a certain way that we do this. So I'm going to delete this. And just as before, I'm now going to say this.name. And now it's going to be fine. So Dart has its own way to instantiate a final property, but now we are sure that it can't be accessed or set. It's still accessible, but it's not settable by something outside our class. So that's actually what we want. So we delete this. And now everything should be working fine. So if we run it, then we should see the names again. In this video, we're going to create methods inside our class. And to do that, we're going back to our code. And if you look in the global scope, you still got some logic with actually belongs to the class itself and not to the global scope, so the rest of the file. That is this make sound method. The global scope shouldn't determine which sound a certain animal makes, but the animal class itself should determine that. So we're going to replace this method by creating some extra methods inside our animal class. And let's start with implementing a property which is called string sound. And I'm going to actually make this private, and then you can see when it's nice to have a private property instead of a property which can be accessed outside the class itself. So here we have a private property, and I'm going to create a method which is called determine sound. And the input of this determine sound method is going to be a kind. And what we're going to do now is cut this code out and put it right back here. And if your code looks a little bit messed up, you can click on this format and then you can see it fixes the format of the code. And what we're going to do now is, instead of printing it out, we're just going to set our sound property with the value that we're going to print out. So we're going to set the sound with woof, and also this mew mew we're going to set our sound with, but let's uppercase the M here and don't forget your semicolon. So to make the sound, we're going to implement another method which is going to be called make sound. So void make sound, and this doesn't need any input because we already have got our sound determined. So we just now can say print sound. The only thing left to do is, inside our constructor, we now call this determine sound method, and then we give in the kind. So now we've done that, we can delete this method and we go up here, and now says make sound animal.kind, but we can now say animal.make sound, semicolon. And if we now run this, let's take a look at it. As you can see, we have still our woof, mew mew, but now also a null value. And that is because of Larry the bird. Because the bird isn't registered, so it doesn't have a sound. And to fix that, we're going to create another structure here. And instead of if, we're going to use else if. This is also better for the performance of the code, because in the old code, it's now going to check if kind is dog. If that's true, it's still going to check if kind is cat, which we actually don't want, because when it's determined, we just want the code to exit this method. So if we use here else if, then it's going to check if the kind is dog. If that's the case, then it's just going to exit our method. And at the last, I'm going to say here else sound is unknown. So now what we have done is, if the kind is dog, then we set it to woof. If the kind is cat, we set it to mew mew. But if this kind can be determined, we're going to set it to unknown. So if we now run the code, then instead of null, we should see unknown. And something that we did on the property, we made this property private by using an underscore. We can also do that for the method, because this method is accessed outside our class, but this one isn't, and we don't want it to actually be called outside it. So we also place an underscore here. Now we get an error, and we're going to place it here as well. And now the only method that is new outside our class is this make sound, but we actually implemented a lot more code than that. So what's really nice about this is that the logic of how the animal behaves is now inside our animal class and is not determined by the code outside. So if we now would be at another file and we would call the same logic, then we are sure that this animal class behaves the same way in different contexts, and not in every file we have to determine which sound a dog makes or which sound a cat makes. No, the class itself determines the sound. And in this way we can design really easy to read code, and it's really easy to comprehend what a certain code is doing. If everyone is going to implement their own implementation on your animal class, you get a really unstructured code and it's really hard to read. So keep that in mind when you're designing how your code should work. In this video we're going to take a look at override methods. So what are override methods? Override methods are methods which are inherited from superclasses or parent classes, whatever you want to call it. So at this point we have our animal class, But behind the scenes, our animal class is actually inheriting from the object class. And this is something that's default in many languages. Every class that you create is a subclass of the object class. And inside this object class, there's a certain method toString. And I'm going to show you that on the internet. So we open up a new browser, and then we say Dart object. And as you can see here, object class Dart.core library. And if you scroll below, it has this toString method, returns a string representation of this object. And our animal class is inheriting this toString method from this object class. And if we now go back to our Dart pad, then if we place an enter here, and I'm going to say animal dot, then you can see that there are certain methods that we never defined, just like this runtime type, no such method, and here the toString method. And this toString method is actually already used, and that's here. This animals class makes use of this toString method to print out this instance of animal, and we are actually able to override that. So how are we able to do this? In the browser, in this environment in which we are programming, I picked this environment because it's really easy to get started, but there are certain limits. So if I type here toString, there's actually nothing happening. If I do console space, then it has no suggestions. But if I open up this code in an environment, and I'm going to use Visual Studio Code. So let's open up this project, and I'm going to replace this here. So here we have our code that we created in the browser. If I now type here toString, then you can see that there's a certain method popping up. If I press enter now, you can see that it has an automatic keyword override, and we can actually see the implementation of this method that we are going to override. So what this method does is it returns super.toString. So it's actually saying that this super is the class where we're inheriting from, which is the object class, and we use the toString method from that object class. And that has its own definition about how that should work. But we don't want that. We want to create our own toString method that whenever it's called, it's giving something back that we want. So I'm going to copy this, and I'm going to close this environment, don't save it, and I'm going to place it here. And instead of this super toString, let's delete this comment, and we're going to say, going to give back a string, which is going to say _name, and then we are going to use our kind again and semicolon. So this is what we had before. It says undefined name of underscore. Oh, we didn't private it, so this way. If we now run the code again, we should see here are animals. As you can see, Harry the dog, Fred the cat, and Larry the bird. So this way we can override certain methods which we are inheriting from other objects. And this is something that we call inheritance, and we're going to look at that in a later video. But here you can see that there's a certain limitation on this browser, this environment, and that's why it's really important that if you really want to get into coding, you should download a good environment, but it takes some setting up time to do that. But it really pays off in the long term. In this video we're going to talk about enums. So what are enums? You could say that an enum is a predetermined list. And the nice thing about enums is that we know what the range of values are because we defined them beforehand. So this might sound a little vague, but if you go into code, it might be a lot easier. So here we are back in our code. And to define an enum, we have to go below here, and instead of using the class keyword, we use the enum keyword. But for what are we going to use this enum? Well, we have this kind property that is a string. And the problem is that we have to check against the string if this kind is the same. And the problem of this is that we use magic strings, which if someone defined this dog with not an uppercase D but a lowercase d, then the sound is not going to be woof, it's going to be unknown probably, but it's still a dog. So we want to take out this kind of confusion by using an enum. And let's first create this enum. So what we do, instead of class, we use enum. And I'm going to name it animal kind. You can name it differently if you want. And it's really simple. We just type dog, cat, bird. So these are the animals that we accept in our animal shelter. Now instead of this string kind, we are now going to use animal kind. But to showcase what this enum does is, we're going to print out animal kind dot values. And inside this animal kind dot values, there is the list of the certain values that we have. So a dog, cat and bird. So what we can do now is, instead of this string, we use animal kind, and now we have a lot of errors, but we're going to fix that by changing this to animal kind. Now this isEmpty is not going to work because this isEmpty is a string function and not an enum function. So we're just going to check for null, and null is the same as undefined. Then we have an error of is determined sound because it expects a string, so we have to change that as well. Then now we can say if kind is animal, don't use that quote, animal kind dot dog and animal kind dot cat. So now all that is fixed, and the only thing that we have to fix is this registering of the animals. So this is also going to be an animal kind. And then we have here that these values aren't animal kinds but strings, so we have to fix that as well. But we can leave the var here and just use animal kind dot dog, animal kind dot cat, animal kind dot bird. And everything should now work fine, just as it did before. But now you don't have to worry about that our string isn't going to match with the input, and if this was the context of a website, we could fill a combo box with these values from our animal kind. So the only thing that's different is that we now have Harry the animal kind dot dog, Fred the animal kind dot cat, and Larry the animal kind dot bird. And we're going to fix that in the next video. In this video, we're going to take a look at getters and setters. So what are getters and setters? So getters and setters give control on how a property should be get or set. So that's really straightforward. And in our case, we're going to take a look at this animal kind. So we have our property animal kind. And now it's public. People can access our kind value and they can manipulate it and do whatever they want with it. But we have now no control of what's going to be inside our kind value. That's why there's a best practice, which is called getters and setters, of course. So we have now a property animal kind, but when we use getters and setters, we use a property animal kind and we make it private. Then we create a getter, for instance, that's going to get a value out of that private value. So we have animal kind, get kind. So the animal kind is our return type. Then we have the get, which says, hey, this is a getter. Then we give it a name. And then we just open up brackets and return this dot kind with the underscore. And this way people can still access our kind value outside our class, but we are in control of what they are going to see. The same is for the setter. The setter is a void method which uses the set keyword, and then we give in the name kind, and we use the animal kind and then a value. So that is the input, and then we set this private value with our value. So to show you what this can do, So let's go to our code and implement this. So the first thing we can do is we're going to set this with a private. And now we're going to see some errors because, hey, there's an underscore and not the not underscore variant. And we're going to fix that by first creating our getter. So we're going to use animal kind and then the get keyword kind. And then we're going to return this kind. And as you can see, our errors will be fixed. But this is the only one that's still there, and that's because this is a setter. We are here setting the value and not getting the value. So we can fix that as well by using void, not animal kind, then set, then kind, and we're going to expect a value here, so animal kind value. And we're going to set our underscore kind with this new value. Now that should be fixed as well. And it's saying something, it says avoid return types on setters. Okay, so we delete that, so that is better. Okay, and if we now run it, then it should be fixed again. So everything works fine. So what we can do now is that for every person that wants to set it with a dog, we can change it to cat, for instance. So if value is animal kind dog, then we're going to say that value is animal kind dot cat. Oh, I have to type it right, of course. So I don't know why you want to do this, but still it's something that we can, so let's do that. If I now run it, this Harry the dog should now be Harry the animal cat. Okay, so what we also could do in our setter is implement this validator, and maybe it's better to set it in here than in the constructor, because we can still set this kind value outside our code so people can access it and give in another value. And if we set it inside here, then we are sure that when it's set in a constructor or when it's set outside the constructor, the input is validated. And I'm going to delete this again because this has no purpose. So if we now run it, then it should still be working, or not. That's also fine. So why isn't it working? It says kind is a 0. If kind is null, then do this. Now, well, kind is not the right value. It should be value. And if we now run it again, then it should be fine. Okay. What we can also do is create a getter that doesn't have a property. So how does this work? We can say string, then get, and we're going to fix that animal kind.dog here, and we just want the dog. So we're going to say string get kind string, and what we're going to do is we are going to get the value from our kind property, so this kind, and we're going to return the value dot toString. Then we're going to split that by this dot here, and then we're going to say that we want a second index. So now what we're going to do is when we ever get this kind string, then we're going to take the value from this property, the underscore kind, and we're going to return that with the value to string. So it's going to read this out. Then we're going to split it by this dot, and that means that we now have two entries in a list, the animal kind and the dog, and we're going to pick the second, which is the dog. And when we return that, then we can write our dog. So instead of here we use kind string. And if we now run it, then it should write out the right way as we expect. So as I mentioned in the last video, we're going to fix this with lambda expressions, and we are actually able to do that. So lambda expressions, also known as arrow functions, are a quick syntax to write a certain code. So how does this work? Instead of this getter with the curly braces, we could also use this arrow operator, and what we're going to do now is we're not going to return because it knows that we're going to return something, but this value doesn't exist. So if I now just use the this underscore kind and delete this left our curly brace, we should be fine again. And if we now run it, we should have the same answer. So as you can see, it's a little bit faster to write this out than the whole curly braces, getting the value, and then afterwards splitting it. So this is what we call an arrow function, and this is something that isn't actually necessary. You can, if you want to write it out in a whole, but if you're experienced, then this may be a quicker syntax to write it out. So we can now use this kind string inside a class, but we are also able to use it outside. So we could say here kind string, and we could run that. And here we get our values back. In this video, we're going to talk about inheritance, and this is the last concept I'm going to do in this tutorial. So this is also one of the more complicated concepts, so if you don't understand it once, I recommend that you look online for some more information and maybe some more examples. But inheritance, we have actually already seen it when we looked at the override methods, because our animal class inherits from the object class. So we can also do that all the way around. We have our animal class, and we can actually have a different class inherit from our animal class. And why would we do that? Well, this could be a design choice, and the way we designed our application is that our animal has an animal kind, and this animal kind determines what kind of animal it is. But what we also could do is, instead of animal kind and then defining all these enum variables, we could also create objects of dog, cat and bird. And what we can do then is place the logic of these separate objects or these separate classes inside the class itself where it belongs to. In a real world scenario, there might be a lot of difference between a dog, cat and bird when it comes to an animal shelter, and that's why it can be handy when these classes are separated. So how does this work in code? Well, you have to bear with me because this is a little bit more complexer, as I already mentioned, but let's dive into our code. So here's where we left off in the last video. And now what we're going to do is create a class, and I'm just going to create one because all three would be a little repetitive. So I'm just going to create one class, and I'm going to create a cat class that inherits this animal class. So how does this work? Well, let's create it. So we create our class cat by using the class keyword and typing the name. And then we use the extends keyword and then animal to say, hey, this class inherits from the animal class. Then it's going to say something about a constructor. The superclass animal doesn't have a zero argument constructor. And what this means is every time we create now an object of our cat class, is actually behind the scenes creating an object of our animal class. And to do that, it needs its properties to register the right information. So what it expects us to do is that we call this constructor and give the information it needs to create an animal class. So let's do that. So what our cat class needs is only the name, because we know the kind when we create the cat class. So what we're going to do is I'm going to define the name again. So final string name, semicolon, and then I'm going to call the constructor. So I'm going to say cat, and then I'm going to say this dot name, just like above here. But I'm not going to give in the kind because we don't need that. Then we need to access the constructor of our superclass or parent class. And as you saw at the override, when we created this toString method, that it calls the super.toString. And just as this super.toString, we need to call the superclass. So we do super, and then we open up brackets, and it knows now that we're trying to use the constructor of our inheriting class, so of our superclass, which is this constructor. And it's going to expect a name and a kind. And what we can do is we can give in the name, so this.name. And now we can give in the animal kind because we already know what it's going to be. So I'm going to say cat, and it has a problem with it. It says invalid reference to this expression, so probably if we delete this, then we're fine. Then a semicolon, and this way we created our cat class. So what we can do now is, just for example reasons, and I'm not saying that this is good code, but we could say that if animal kind, if kind is this animal kind dot cat, we are creating a cat class instead of an animal class. We're just giving in the name, and then we're going to add it to the animals. And we're going to put this in else, and I'm going to leave outside the print statement because I want to use that. Oh, this is not animal, this is cat. So I'm going to click the format here, so it looks a little bit better. Okay, so why can we add the cat class here? Well, that's because we are inheriting from the animal class, so it says, hey, this is also an animal class, but it's of type cat, and that's fine. So first, let's just run this, okay, and see if it's still working. So we have Fred the cat, Harry the dog, and as you can see, we have still the woof, mew mew, but we are missing the print name, and that's because it's gone here. So I'm just going to delete here, so it wasn't there anymore, and that's why we don't see the name. And I'm going to run it again, and now the names are disappeared, and now move, mew mew, and unknown. So that's working fine. Now what we can also do, just like with the toString, we can override the method. And a method that we would want to override is this determine sound, because it's not necessary anymore. We already know what the sound is going to be. So first let's just override that. And there's actually a better way to fix this, but still, let's just do that first. So we override, not a double V, override, and then we say void determine sound. And then I'm going to have to make the same, I have to make sure that this looks the same as this one, because otherwise it isn't going to override it. So I'm still going to expect the animal kind. And then I'm just going to say this.sound, and as you can see, I can access the variables that are in our animal class and not in our cat class. That's because of the inheritance. So now I can set this to mew mew mew. And let's check this out if this works. So I expect here now mew mew mew. And as you can see, it's working. So that's really nice. And we could also do this for the dog and for the bird. And this way we can make sure that the logic is in the class that we expect it to be and not in the animal class. If we don't have the class for the animal itself, when it comes into our shelter, so let's say a giraffe, then we can let it make use of this animal class, and later on we create the giraffe class. But for now, let's focus on this cat class, because this is really nice, but there's actually a much more simpler way to override this sound method, and that's to override it directly. So I'm going to delete this again. I like my classes in order, so I like my classes the way they are designed at this moment. I want my properties on the top, getters and setters after that, then a constructor, and then our methods. This way I know where my properties are, where my getters and setters are, constructors, and where my methods, so it's really easy to navigate through my files, and it's much more easy to navigate when this is a big file at the moment. So what we can do is also override properties. So we can do override, not a double V again, and now we can just pick this property. And we can use a lambda expression again, because we just wanted to override this property. And we already know what it's going to give back. We don't want to set it again anymore, so we just want to override it. And now it's going to say class get can define method underscore sound and have fields animal underscore sound with the same name. Methods must have an explicit list of parameters. So the way we can fix that is just by setting the get before it. So now we say when we get this underscore sound, then I expect mu mu mu. And let's just add another mu to show that it's overriding the sound property. And as you can see, for mu's now, so that's working. As you can see, along this tutorial, we build a really big file. So normally, when you work inside the editor, just like Visual Studio Code, I would recommend to do this in separate files because it's really hard to oversee what's going on at the moment. Actually, the last thing that I want to do is, now as you can see, it is still saying Harry the dog, Fred the cat, and Larry the bird, and that's because of our toString method. But if I now delete this, then it's going to show which class it is, so instance of animal and stuff like that. And as we expect, probably, so this is going to be instance of animal, this is going to be instance of animal, but this is going to be instance of cat. So let's run this and confirm it. And as you can see, it's instance of cat. So I'm going to leave it here for now. If you want to implement the dog and the bird class, I would really recommend it so you can practice a little more with